Hello and welcome to this edition of EMS Now Up Close. I'm Eric Miskell with EMS Now, and it's my pleasure today to welcome back Brian O'Leary. Brian is the Global Head of E-Mobility and Infrastructure with the Indium Corporation. Brian, we spoke once before. You were on one of my shows discussing the EV industry, and wanted to have you back and speak more specifically about the EV industry in Europe today. So I welcome the opportunity for another discussion with you. For those who may not know you, why don't you take a moment and introduce yourself and say something about Indium Corp.
All right, thank you, Eric. So just a little bit about myself and Indium. I am focused on EV within my company. We are a supplier of soldering and soldering related type materials, also thermal as well. And where we play in the world of EVs, obviously, is on the printed circuit boards. But we also provide materials that are in the stack up of the inverter, which is a key part of the whole EV system, and more on the thermal management side of the equation. But you know, it's an interesting time. It's fascinating. This industry is moving super fast, and I'm sure we're going to talk a little bit about standards and what's keeping up, what's not keeping up. So fire away.
Good. Let's start big picture. I think that, and again, focused on Europe. A lot of people kind of assume that Europe is ahead of where North America is in terms of adoption of EV. And I know you use the term ICE, internal combustion engine, to kind of differentiate between, standard traditional vehicles and what's coming. How is that in Europe? How's that? How would you characterize the market over there and what's happening?
Yeah, I think that's a fair characterization. I mean, with maybe the exception of Tesla, who's been the market leader, as far as a market, European market, definitely their adoption is much higher than the United States. There's certainly a wider range of products available currently on the road. You've got extreme examples like Norway. Adoption is just mind-boggling. They pretty much have stopped buying diesel altogether, and fossil fuel-based systems are on the outs. So, but things are changing very rapidly in each of these markets. I mean, the U.S. is playing catch-up, but yes, the Europeans definitely are leading in many respects.
Yeah. So, how does that impact from a manufacturing perspective? You think about kind of the traditional model of the automotive industry with all these tiered suppliers, providing the, various services and various sub-assemblies, so to speak, to go to that. How is EV changing that landscape within automotive for these companies?
Well, I mean, we've seen some pretty dramatic announcements over the last just couple of years of manufacturers saying that they're going to get out of the combustion engine business. Those who are still building that side of the, building vehicles for that side have also announced, many of them, that they are no longer funding R&D. So the writing is on the wall. I mean, there is a hard pivot going on right now. I mean, Volkswagen, I think, is a great example of a major European player that is all in. I mean, it's dramatic, the resources and money that they are putting into an EV future. And as far as how that's shaking up the industry, you see partnerships that were unimaginable. For example, the MEB platform, I'm going to use Volkswagen as an example, is going to be sold to Ford, and Ford's going to build on top of that. They're also working together jointly on the autopilot, or the AI aspect of a vehicle. And you also see a big shakeup in supply chain in terms of tier ones and tier twos and how they behave. And, in a nutshell, the tier ones were largely building a mechanical assembly. And today's EVs are a fraction, something along the lines of 3 to 6% the mechanical or moving parts of an ICE vehicle. And so the tier ones who are building mechanical are now just building electronics for the most part, which allows the tier twos to basically contract directly with the OEMs. So that is a huge shakeup in the industry.
Yeah. And, the other one that you mentioned is Volvo, I know, has made a real commitment to going all EV by end of this decade for sure. So, and clearly Swedish based there as well. Now, related to the vehicles is obviously the infrastructure, which one thinks charging stations in that regard. How is how does that evolve? What are the opportunities there? And is this in some way a hindrance to the growth of EV?
I would say kind of yes and no. Yes, it's going to be a hindrance in terms of you're going to have frustrated consumers if charging is not ready, because it's coming, like it or not. I don't think it's going to slow down the number of EVs that are sold and produced. But let's get real for a moment. And there's a lot of misunderstandings when it comes to charging. All the focus, it seems to be on the DC fast chargers. You know, those are the systems that you can pull up, and it's analogous to like fueling up your car today. It takes about 8 to 10, maybe 15 minutes to fully fill your vehicle. But in Europe, you know, the average EU driver only drives about 11,000 kilometers a year. That roughly comes out to about 30 kilometers a day. And most chargers that you would find in a garage or publicly that are not DC fast chargers are going to give you the range. So these DC fast chargers really come into play when you're going to make that occasional long trip from France to Italy or something like that. But that seems where a lot of the focus is these days, and the public money and the technology advancements is pretty remarkable. I mean, ABB, for example, just installed their Terra 360 in Norway, and this is the biggest and baddest fast charger on the market now. It's 360 kilowatts. It can charge 2 vehicles simultaneously, and they report on their website you can get a full charge in under 15 minutes, or you can add about 100 kilometers in 3 minutes. So I think it's going to help a lot, these fast chargers, in kind of addressing this range anxiety people have in their head. You know, what happens if I run out of a charge? But the reality is we're all going to learn new behaviors, and you know, you talk to EV users, they don't worry about charging. It's really not a problem.
And that's an excellent point within Europe, where, you know, I know here, I live in Texas, right? I've driven with somebody in an EV where you're doing 300 miles in a day. You know,
right.
Really have to plan where you're going and get the recharge in order to, you know, to complete that journey. At least we did. So it's true. I could see that in Europe being less of a challenge then. So, but, you know, when we think EV, you know, I think of the traditional cars, but EV, and you discuss this as part of a larger kind of an e-mobility ecosystem, right? So it's really beyond automotive, and it includes a lot of other types of vehicles. Speak to that and how that is in Europe as well.
Well, you know, one of the issues, and it couldn't be more stark in Europe right now, is energy security. I mean, what's happening in Ukraine and Russia, and this is ushering, I think, a fast track to being able to have energy on demand, being able to store energy, being able to rely more heavily on renewables. I mean, the reality is, you know, a lot of renewables is not being captured. You know, when the sun shines, it's all on, and you've got all this energy all of a sudden, but you got to have somewhere to put it. And what EVs and the vehicles themselves, as well as that larger ecosystem, which includes battery storage, is really going to be a game changer. You just think of it this way, you know, governments don't necessarily even have to invest in massive storage. They could use all these EVs plugged into your home that have that bi-directional charging capability, which means they not only can pull energy from the grid to charge the vehicle, but they can also give it back. So, you know, I think like you could picture in your mind is you go to work, you park your car out in the lot. Maybe there's solar collectors, maybe not, maybe there's wind. But those renewables are charging those batteries all day. And then you go home and maybe you say with your app, hey, I'm going to dump 60% in the grid, and it's going to pay for my dinner. And I'm going to hold on to the other 40% so I can get to work tomorrow. So those types of things are coming. And I think it's coming much sooner than later.
Yeah. And the type of vehicles aren't just, because you've talked, I know, and I like your presentation a lot, like yard trucks. And you talk about these other things, and it's expanding beyond just kind of automotive type vehicles into potentially into marine vehicles and even, you know, air taxis, so to speak. So,
yeah, I mean, the modes of transportation are really just leave it to your imagination. It goes everything from what is calling what's termed micro mobility. So those are like your two-wheelers, could be even a mountain bike or a scooter. all the way up to like air taxis, like you said. Electrification of trains is even being talked about. Well, trains have been electrified for a long time, but we're talking, massive freight trains now running off of batteries. It's quite remarkable. And, I saw an article not too long ago that there's even some ex-Tesla guys working on a project where the individual rail cars are under their own power, can kind of disconnect like Lego blocks and go on their own way with AI. It's just, it's pretty
Oh my
mind-boggling.
gosh.
Yeah.
Yeah. Yeah. Now, and you touched on an issue there that I find fascinating with this, and it's that vehicle to X, or vehicle, you can take that vehicle once it's charged, and it's not just a consumer of the electricity, but it could also be, it's a producer and a storage place for it. So that whole, I think you call it vehicle to vehicle, vehicle to home, vehicle to building, vehicle to grid. There's so much potential there. Is that the same in Europe? Are they using it the same ways?
Actually, I think if there was a leader, Europe seems to be kind of out ahead of this. When you look at the bi-directional technology, I mean, the Nissan Leaf has had it all these years, but has never been used. But my understanding is all the VW products going out now have this bi-directionality. It was at least talked about a couple of years ago that this whole concept of having all these batteries in people's garages, and the German government being able to pull from that as an energy source.
Mhm.
I'm sure they're talking about it now. And
Yeah, I'd
what's
imagine
going
so.
on. I mean,
Right.
it's an elegant solution to a problem. And it also, what's interesting, it helps address the issues we're going to have with balancing the grid as well. I mean, when you have all these EVs go online, and suddenly, it's peak demand and people want to pull from the grid. If you've got this battery storage component to it, it's going to help the operators better balance the grid. I mean, I'm no expert on energy and the grid in Europe, but I can tell you here in the United States, it's an absolute mess. And I have to imagine in Europe, each country probably does kind of its own thing. So this is an elegant solution, which it's kind of akin to like the iPhone in some respects, or mobile phones. It's like, Africa never got around, many countries never got around to laying copper wire, and they were able to just like leapfrog over the technology with cellular.
Mhm.
And I think, this whole EV batteries is going to allow places that maybe have a very fragile grid to suddenly be quite robust.
Yeah. Now, we've been talking about the big picture of the EV in the market and what's happening there, but let's talk a little bit about the challenges that EV poses for PCBA, right?
Yeah.
This isn't just a simple, switch over. Speak to that. Tell me about those challenges in doing PCBAs for EV.
So this is something that occupies a lot of my time, certainly, because what we're finding in practice is a lot of these builds are being held to or have requirements we call the mission profiles. That's kind of the duty cycle, much more challenging than a traditional ICE type of electronics. Just give some examples. An EV is always on, right? It's when it's charging, it's on. When it's communicating with the grid, it's on. It's doing a lot more. And then you couple that with, some of the AI features. You find the processors that are now going into the infotainment systems to be. You look at these boards; they look like a board that you just pulled out of a Cisco router. Nothing like what we saw years ago. So, what's happening though is the standards that are used for test. A lot of them are frankly just not keeping up. I give an example. The J standard 004B well, I should say that is a good example of where it is being addressed, but the standard hasn't been adopted yet. But industry is saying, hey, look, 100 mega ohms for like SIR requirements, which is a test of quality.
Mhm.
In terms of if you're going to get a short on your board, that's something that is very
Mhm.
common when with our materials with solder paste. The old standard was looking at 100 hours. That's just not enough. I'm sorry, 168 hours. Today they're looking at 1,000 hours. And if you look at the components on the board, the old standard was like 0.5 mm pitch, but these infotainment boards now are more typically around the range of 0.2 mm. Another part of the standard, the old voltage requirements was only 5 volts. I mean, these boards are running 10, 50 volts.
Yeah.
So this is a case where industry is kind of needing to catch up. But then, and another aspect of this, voiding is something that's always been a big topic. IPC just adopted a new standard on voiding, thank goodness. That's IPCA 610 that now looks component by component and doesn't just lump it all as a spec for a BGA. So it's sometimes we're there, sometimes we're not. And what myself and several of our colleagues, we've kind of banded together recently through IPC as an advisory group to EV. And it's not to establish standards, but rather to share best practices with our industry internally. Just because we're all learning this as we go. It's like we're making the plane as we're flying it. So, and seriously, if any of the listeners on this call is in the EMS world and would like to participate, by all means, our next meeting is on May 18th, and all are welcome to give input to this exciting industry.
Yeah. So who is leading that and setting the standards? Is it the IPC in this case?
Well, what we're finding in practice, at least in my world, a lot of it is actually coming out of Germany right now with DKE. And through DKE, which is kind of a sub part of IEC, that information is being shared with IPC. So it seems like it's kind of flowing from Germany, and some of these requirements are being adopted by IPC. So the example of the A-610, that originated from DKE, and now it's an IPC spec.
I see. So, the other question I wanted to ask, and as you were speaking there, is you were talking about the Indium products and kind of the challenging and now the different standards but what adjustments, changes is it enforcing, or is EV forcing on your product development? Is it just the standard and how you utilize it component to component, or is there is it requiring new materials as well?
Well, fortunate for us, when I was talking about the J standard 004B, we do have a material that is able to hold up to a more rigorous like SIR requirement. That's something we worked on several years ago, and the industry is just kind of catching up to it now. In the respect to some of the rigors of a higher emission profile, temperature is coming into play. So a lot of us manufacturers are looking at alloy changes that can meet those higher temperatures. So the answer is yes. I mean, we are needing all the time to reevaluate our current products to meet these new requirements. I mean, within the inverter alone, these manufacturers are trying to do things that have never been done, quite frankly. And it's real key for many of us. And part of this consortium I was talking about at IPC is we need to make partnerships, have to have open communication. Because when you're developing something new, it's very, very difficult to do it in isolation. So we work closely with our customers, obviously.
Yeah. Okay. So tell me about what you see kind of moving forward for EV in the market, but also specifically in Europe. Any predictions on kind of how this is going to roll out over the next few years? Is any challenges that we face that we need to be talking about?
I call it the Wild West, and I stand by that. I think expectations, we've kind of gotten up, beyond our skis to say. I think batteries and the ability to source batteries as a manufacturer of an EV is going to be extremely challenging. There's a lot of work being done right now in Europe to build battery plants. I know there's one going in Italy. There's just talk the other day about Spain. They can't build them fast enough. And the real bottleneck, sort of the boogeyman in the room, is there's only one place in the world that can process the raw materials that go into batteries, and that is China. They started working on it 10 years ago. So it's going to be tough. It's going to be a bumpy road. And, frankly, I mean, perfect example, Volkswagen is doing well, but they've already made an announcement this week that they're at capacity. They're not taking any more orders for this year. They're done. And a lot of other manufacturers are kind of in the same boat. It's not, they don't have the materials or any one reason. It's just they're at capacity. The demand is outstripping supply.
Yeah. Yeah. And I know, what is the company? Northvolt, I think, is the big European battery company that has been developing over there. A lot of ex-Tesla people I know have gone to work there, and they're seemingly growing. They're up in Scandinavia, I believe,
Right.
is headquartered, and making some moves. And, so you see that kind of Europe, the domestic industry kind of responding to the challenges that you're talking about as well. So good stuff. Okay, well, Brian, we've come to the end of this discussion. I'm sure we'll speak again, because this is obviously a hot topic and will continue to be for years forward for our audience, especially those in the EMS industry. So I'd like to just thank you for your time, for your insights. And hopefully we do this again later in the year. And by the way, for the people out there watching, I met Brian because I went to a local SMTA show here in Dallas and got to see his presentation. And if you have an opportunity to see that, it's very, very informative. And it really stimulates a lot of thought about what's happening and where we're going. So I encourage anybody out there to check out Brian when he comes to a SMTA show near you, right? So,
In Michigan next week. So there you go.
There we go. Okay. So excellent. Brian, thank you very much, sir. I appreciate your time.
All right. Thanks, Eric. Take care.
You too.
Bye.